Okay, today what we're going to do is we're going to solve right triangles. We're going to use all that information that we've learned over the last 3 classes and mix it all up. Um, Solving right triangle means to determine all the unknown sides and unknown angles in a triangle. And any of the 3 trig ratios we have learned so far can help us solve a triangle. So what I've done, and I've done this pre-ahead, so you might want to pause um, as I go through, but here's the summary of the primary trig ratios. Here's our one triangle, and the words of the triangle are opposite, adjacent, hypotenuse. And here they are, and these words are relative to angle A. So if we look at the vertical side BC, that is opposite of angle A. And if we look at the horizontal side AC, that is adjacent to angle A. And of course, the hypotenuse is always the hypotenuse. It is not relative to anything. If we're talking about angle B, opposite and adjacent would flip. So here's what I've done. I've summarized the things for you. You might pause right now and copy that down. It's all in your notes. Okay, now that you've done that, there's a really nice little mnemonic that helps you remember which ratio to use. And I learned this when I was a kid, and it stuck with me. And the mnemonic is SOHCAHTOA, SOHCAHTOA. And this is just a simple way of remembering, based on the information you're given, which one of the ratios you use. Now, again, you have your blue card, and this is on your blue card, but you really don't need it. So, to have a quick look, SOHCAHTOA, there's the S, and there's the O and the H. So if you have opposite hypotenuse, you can use the sine ratio. There's the CAH, C-A-H. If you have the adjacent hypotenuse information, you're going to use the cosine, and there's the T and the OA. If you have that information, you're going to use that ratio. So this is a nice way to remember them all in one go. Okay, let's look at an example solving the following triangle. So in this question, what I want to do is to be able to figure out all the unknown sides. I want to figure out angle K, angle N, and I'm going to call it little m, which is the hypotenuse. And it doesn't matter how you do it, order. What you really want to do is you want to use the information that's given and not, if possible, use the information you've determined. So I'm going to find little m first. And the way I'm going to find little m is I'm going to use Pythagorean theorem because I have 2 sides of a right triangle and I want to find the hypotenuse, and that's the one I'm most confident in. And when I do that, I can do that very quickly. And when I take the square root and I round the answer to 1 decimal place, it's 13.0. Now, in order to find an angle, I cannot use Pythagorean theorem. And which angle I find first doesn't matter. So what I'm going to do is I'm going to find angle K first. And if I look at angle K, then I ask myself, okay, what information do I have relative to angle K? And it's given information. Well, what I know with angle K is I know the side opposite angle K, that's 11. And I know the side adjacent to angle K, that is 7. And I want to know angle K. Now I know above, I figured out the hypotenuse, and I actually know the hypotenuse, but I don't want to use that information because I might have made a mistake. And of course this calls out the tangent ratio. And our tangent ratio is the tangent of an angle, and in this case it's angle K, is equal to how long the side opposite to how long the adjacent side is. And in order to find an angle, we have to press a button on our calculator, plug in the ratio, and our calculator will toss out 58 degrees. Now, given I know angle K, I know angle N. When I add up the interior angles of a triangle, it all adds up to 180 degrees. But if I made a mistake with angle K, then my angle N is wrong as well. So I'm going to go ahead and I'm going to do the exact same thing. as I did above. Okay, what I know. Well, relative to angle N, I know this side, which is the opposite side. I know this side, which is the adjacent to angle N. And I want to know angle N. And again, what that points me to is the tangent ratio. So here's our OA. And the tangent of an angle, in this case it's angle N, is equal to the side opposite, which is 7, adjacent is 11. And in order to figure out our angle, we're going to press that button on our calculator, and our calculator is going to spit out 32 degrees as expected. Okay, so let's look at one quick example. A ladder, two quick examples, a ladder leaning against the wall. What I'd recommend you do first is a quick physical little picture. Here's my ground, here's my wall, here's my ladder. And when you do that, what you end up with, you'll end up with a picture, a triangle. So then what I want to do is I want to go from this picture to my triangle, and I want to label everything I know. Well, I'm assuming that's a 90-degree angle where the ground meets the wall. My ladder is the hypotenuse, and the lower end of my ladder is 2 meters away from the wall. And what I want to determine is the angle of inclination. So there's my angle of inclination right there. Again, we did this when we did that in measurable height. And now I can go about doing my trigonometry. I can't use Pythagoras. Oh, sorry. The other thing I want to figure out is I want to figure out how high up the wall it goes. So what I can do is I want to know how high up it goes up the wall. I can use Pythagoras to find x. And it's x squared plus 2 squared is equal to 10 squared. And when we go ahead and do that, we get x squared is equal to 96. X is equal to 9.8 meters. Okay, so there's how far it went up the wall using Pythagoras. I'm going to call this angle A. My next thing is I want to find the angle of inclination, which is finding angle A. So I go through my process, what I know. Well, I know the side adjacent to angle A, that's 2. I know the hypotenuse, that's 10, and I want to know angle A. And again, hopefully with SOHCAHTOA, we have the A and the H, ka. There is our ratio cosine. And our cosine ratio is the cosine of an angle, well, that's A, is equal to adjacent over hypotenuse. And now we press our buttons on our calculator. And when we do that, we get 78 degrees, which is a steep angle, which kind of makes sense because our ladder is not far away from the wall. Okay, let's do one last example. And again, so being able to translate the words into a picture. From a point on the ground 20 meters away from a flagpole, the angle of inclination to the top of the flagpole is 72 degrees. How high is the flagpole? So let's draw a physical picture. Here's the ground, here's my flagpole. We're over here somewhere on the ground, and we are looking up to the top of the flagpole. So here is my picture. And what I want to do then is, well, transfer all that information away and just make my triangle. So again, I'm assuming the flagpole is straight up and down. I know that the point over here is 20 meters away, and I know that the angle of inclination is 72 degrees. And I want to know how high the flagpole is. So there's my picture, and now I go through my process. What I know. Well, let me see. I'm going to call this angle A. I know angle A. I know the side adjacent to angle A, and I want to know the side opposite of angle A. And here's that information that tells me which ratio to use. SOHCAHTOA. There's the O and the A. There's my tangent ratio. So the tangent of my angle, and my angle here is 72 degrees, is equal to x over 20. And the way we solve this kind of equation is we multiply both sides by 20 because this thing here says x divided by 20, and we undo a division with a multiplication. And when we go ahead and do that, we end up with x is equal to 20 times 10 of 72, which is equal to 61.6 meters. So there's 3 examples with mixing things up, finding particular information based on what you have. And that's what we're going to do over the next 2 days, just mix things up. What I'd like you to do is to go into your glossary at the back of your book where you have definitions, or go online and find these definitions, and make sure you come to class next day with these definitions recorded.